Hello everyone and welcome to the final tutorial. Um this week, I don't know why smart screen's going off, but this week we're actually going to be doing something fun. Um just it's going to be water and terrain basically. Um and there'll be an ILE at the end. Your ILE will be something simple like just improve the look of the scene. And you can do that by adding texture mixing to the terrain, by adding normals to the water and mixing them to make them look better. You can easily find tutorials for that online. Um, by even adding a flow map, which is something that you can also find pretty easily online. Um, Basically, it'll be anything you want, just as long as you make an improvement to the scene, and that'll be your final ILE. Um, it can take as little or as long as you'd like. Um, if you just want to add like a few objects to the scene to make it look, better. If you want to change the texture to a beach and then add some beach chairs, go ahead. That's a great ILE. But for now, um, let's get right into it. Apologies that this video is coming out on Monday. I finished this last night. This tutorial was entirely done. But there was an issue with the recording, so I have to re-record it. Didn't have audio for some reason, so that was unfortunate. Given that audio is most of the video. Um, but yeah, today's video won't be very long. Honestly, I think it'll take probably like really won't take that long. It'll probably take like 30-40 minutes. If that. So first thing we're gonna do is we're gonna create two shaders. And the first shader we are just going to call, you know, ground shader. And I'm sure you've all created a displacement shader before, given that it was an assignment last semester. Uh, but we're just gonna make one of those, quite literally. Um, and then the second one is gonna be water shader, water shader, water shader. Oh, water shader. And then it's pretty much just I'm gonna call it water vert and water grad. Um, from there, everything. There you go. IntelliSense was being weird. Um, but so I want us to have some controls. So what we're going to do is allow ourselves to create some ImGUI controls for our materials, which requires us to actually move our grass material over here. And that's all. So we're only gonna be working with with the ground shader first because I want to show you the progression of the scene as it slowly gets better and better. So if GUI header world if GUI slider oh slider float height intensity. Intensity. And then it has a minimum of 1 and a maximum of 100. And then all we're going to do in here is set, and we're going to call our uniform height intensity. And so whenever, we slide this, it's just going to update our uniform. Now we want to go down here to where our grass mat is created. You'll notice that they're both called grass mat. So the issue with that, we have duplicates, and we don't want duplicates. But if you look here, we want to also have it default to whatever value we default our thing to. So we just add it there. Other than that, we really don't want, like, we don't want random generation right now. It's just not useful, really. But the biggest thing that we want to enable right now is something that isn't actually enabled in the tutorial framework. Blending. I realized this while I was writing this tutorial. Transparency is not enabled. So we're just telling it how it should be blended. Like, so when you draw a transparent object, how should everything be blended? That's the gist of that. It's really not too complicated. The big thing that we want to do is if we actually go into here, go into samples, week 7, resources, images, you'll notice that I have some new images. I even included some, how I mentioned that you could add normals as far as like your ILE. I included some normals that you could blend with. So we have our water shader, and we have a new dirt shader, and I like this one. It gives it like a sort of tundra vibe. So I ended up swapping out grass.jpg for dirt.jpg. And then the other thing that we need to do is send in a height map, which if you look right here, it's right there. We have a height map. Texture. Oh. Load from file. And then that's it. Oh. I hate it when I press Control A instead. And then the big thing that we just want to do is set, and we're going to call it S. We're just going to call it S height. And this way, it's sent into our shader before we even start working on it. And yeah. Yeah, that's pretty much it for right now. Actually, there is one thing that I should mention. I made a few changes. There's this. This is a variable now. Total time. Oh, accidentally moved something. But the gist is you see right here where it calculates delta time and the current frame time. So you just we're just gonna, and this will make sense later why we're adding all of this. but the gist is we're just updating time and making sure that we have a total time variable. And this is cool for any continuous effect that uses something like sine. Um, yeah. And the last thing that we added, or that I added, was render is transparent. And so we're gonna add the code that uses that right now. But the gist is we're actually checking if it's a transparent object, um, and then if it is, uh, we're binding the depth as texture because right now the only transparent object that we have is going to be our water. And we're also setting GL depth mask. Oh, GL depth mask to GL false. So what this does is it isn't as permanent as disabling. Um, what's it called? If it isn't as permanent as disabling GL depth test. GL depth test. Apologies. Tongue twister. Um, and basically it allows you to draw objects, still have their depth get tested, so you can still access all that information. Like their depth test information is still all there. It's just not getting written to your depth texture, which is really cool and very useful, just overall, because using the mask instead of um, disabling, like if we go up here, we could, where is it? If we go all the way up here, we could disable the depth test and mess around with that. But the issue is we don't want to do that. We actually need the depth because that is actually part of the main final product that we are creating. Um, from here, we just need to go into our shader folder, create new text file, um, height, vert, JPlus. Let me just gotta open it. And now, pretty much, it's going to be pretty much identical to what we have in our um, go the vertex shader. We could quite literally just Control A, copy paste this, and then um, because we are actually still sending all the data necessary to to have it do everything. Uh, because we are still, if we look up here, we're still making it use the directional blend plong, and that actually reminds. There it is. We need to make this so dot set cache shadow false, and that just makes it so the ground doesn't, when it deforms, doesn't cast shadows on itself because we don't want it to render in our shadow buffer. It'll cover up a lot. And that's a big thing. This is not the deferred rendering one. This is forward rendering because we're working with transparents. Transparents don't like deferred rendering. And so typically what you'd do is you'd have a deferred rendering pass and then a separate forward rendering pass. In this case, because I wanted to make it as simple as possible, didn't want to overwhelm. Basically, all that I've done is I've made it so that I'm just using forward rendering for this starter. Um, but yeah, over here we gotta add our height And then let me call it height intensity. And so what we want to create is our displacement value. And so I'm sure you all remember, but height maps are meant to be -1 to 1. So for example, um, you know, but sorry, height maps are supposed to be -1 to 1. Sorry, I can't speak when I'm typing, but um, height maps are meant to be -1 to 1. But a texture is 0 to 1. So what we're going to do is we're going to multiply it by 2 to make it 0 to 2, and then -1 to make it -1 to 1. And that just unpacks it, is the gist of what we just did there. And then from here, we're actually going to calculate our displacement vertice. So we're going to read in position, convert it, and then plus vec4. And then because z is up in this, we're going to do height intensity. And then we're going to multiply it by our displacement value. So if height intensity is 5, it's going to get multiplied by the displacement. And technically, like, most times you have 1, but the reason why this actually gives us control over our height, which I think is important. Like, it gives us full control over everything, and like, so now we have an ImGUI slider that actually lets us control the height intensity, which I think is really important. And then quite literally, we just replace converge. We just replace it. And that's quite literally, other than this. Remember that we pass in this so that we can in-pause, or out-pause is in-pause in the fragment shader. But the idea is that that's used for lighting. But because we're displacing the vertex, we want to send in the displaced vertex, not the like pre-displacement vertex. And if we run it now, this should build, and it, oh, I forgot. Always forget that. I'm not used to using multiple projects, but the idea is that right now when we run it, we should end up getting a controllable and very editable, like with ImGUI, height displacement map, so displaced ground. If you're wondering about the plane not having enough verts, I replaced the plane that was in there with one that I tessellated in order to make it so it had more verts. Yeah, and that's pretty much it. I just replaced it with a more tessellated plane that wasn't just 2 triangles. Because with 2 triangles, there's not nearly enough information for you to, you know, for you to finish with everything. But as you can see, no errors in the shader. Oh, wait, sorry, as you can't see there. Interesting. That's never happened. Continue. Interesting. Did not get this error ever. Interesting. One second. I guess it's debugging time. That happens sometimes, I guess. Grass mat. Uh, Interesting. That's let's try running it again. There's no errors in the console. Access. That's really weird. The shader's valid. Um, well, I'm gonna pause the recording and see if I can't fix this. Um, I will see you in a second. Welcome back. Um, so it turned out the issue was actually just a copy paste error. Um, yeah, no. When we copy pasted from here, seems there was an empty you know, messed up line ending. Um, on at least one of these lines, I rewrote the entire thing. Um, and that fixed it. Couldn't tell you what specifically was wrong, but I know it was an issue with this because it was an OpenGL error. They couldn't find the um, the uniform location through the OpenGL DLL. Um, but if we run now, and as for if you run into the same issue, just go in and rewrite your shader. Delete the lines entirely and like just write them out one by one. It is tedious and exactly what I wanted to avoid making how you guys do, but you know, sometimes OpenGL is prissy. Yeah. So we've got deforming ground that we can actually control the amount. Um, yeah. So that is one part of our system down. Um, Pretty much now we just need to finish setting up all of the stuff for the water to let us have control over everything. Um, and for that, we're gonna want to make just a few small changes. So first things first, we wrote this before, uncomment it. We're gonna use it now. Um, and from here, going to we want to have I like having full control over things like this, so full control over water transparency. And then, so the way that this is going to work is we're actually going to split up our water based on the depth. And so for this, I've done some testing, and when I was making this, and I got some pretty nice colors that I personally enjoy. Um, Vec 4. 5.0.0 G4. And then now we're going to choose where our shore cuts off. And I'm going to choose 0.03. And then material, water mat. And then, so this is actually important. So currently the previous TA already actually put in a system for render layers. And transparents need to be drawn last, obviously. They can't be drawn before, an opaque object is. So if you actually look at this sort function right down here, you'll notice that if the render layer is higher up, it gets drawn last, basically. So the idea here is that we're going to sort, or we're going to set our render layer pretty far back, just to make this easier on us. And you'll see later on why I can set it separately. So technically, because we only have 3 objects in our scene, it's not going to be a big issue. It really isn't, even if we didn't set the render layer. If I'm honest, I actually believe um, the water is going to get drawn last anyways. But it's good practice. It's a good, you should have a separate render layer for your transparent objects. So now we're going to control. We're going to just create a separator. Water controls, and we're going to just call this area ground controls. If HimGUI color edit or deep color value pointer color, and then we're just going to call this deepest color. Color. And keep in mind, you can change any of these variable names if you would like. You can also just skip this portion of the tutorial if you don't want controls. But I will tell you that it makes it fun to mess around with, and it's cool in general. But still, it's entirely up to you. I'm not requiring that you have the various editors for your ILE. Value pointer, shore color. And then water mat, set. And that's what we're going to call our variable. And then from there, we're just going to change a few. Slider float, shore cutoff. And so this is the point where the from 0 to shore, shore cutoff, this is the point where it turns into the middle color. And I should actually mention, there's going to be a piece of unoptimized code purposefully in this shader. And as an option for your ILE, you could optimize that code to use something like mix instead, um, to use like built-in functions instead of if statements. And I left it like that just so that there can be an option for anyone that wants to do artistic stuff and make it look good. Anyone that wants to do more graphics programming, so like implementing like uh, normal maps and stuff like that. Um, and then from there, um, yeah, I just left it so it was very open ended. Given that this is your last, like your very last ILE, I wanted to make your lives easy. Because you do have GDW due on Friday. Um, so I wanted to give you like something that you could do easily in like 5 minutes. You could just add some like objects and say it's pretty now, you know? I'm not gonna look too closely. Um, but one big thing to notice here is so I've actually set the shore cutoff to have a max of mid cutoff so that they can't overlap each other. And then mid cutoff has a min of shore cutoff so that it can't go past it. Oh, I didn't even write set. That is funny. Um, that should yeah, no, it worked. It's just my IntelliSense being weird. From here we actually want to texture to the water. Images, water.png. And we have our water down here. It's just a simple clouded image that I colored. Just to give the water some depth, really. Um, so the big thing that we want to do now is we need to create, we've already created, if you go up here, we already have our water mat. We just need to make sure to set all the variables. So to start off with, I'm just gonna copy these. And I know copy pasting has gotten in trouble before, but it's as long as you're not copying an entire file was a mistake. I will say that without a doubt. So we just put water and water, or sorry, no spec. You can change this and make it have more spec. I'm gonna change the shininess factor to 8, so that it actually has um, more specular reflections. Um, from here, you see all of these different settings. You know what I forgot? I just realized. ImGUI slider float, um, water transparency, and then so it's got a minimum 0.01 and then a maximum 1.0. And it's just water mat set. And there we go. Almost forgot to have the water transparency display in there. So the big thing here is we just got to write a lot of, water mat set. We called that water transparency. Be careful about typos. Just remember that if it's a typo, it won't send properly to the shader. which means that your values you'll probably be getting something different from what I see. One of the big things that we're going to be doing in this tutorial in a few minutes, once we get to the shader, is we're going to be running it every little bit just to see what specifically we're doing. Because I think this is by far one of the cooler things that we're going to do, or that we've done in this semester. I spelt water mat above wrong. I will fix that. Shore color. Switch that to a capital. Set. You shore cutoff. Shore cutoff. You mid cutoff. Mid cutoff. There we go. And everything, everything's done over here. Everything's done over here. Now one of the big things we need to do is actually copy. And so, one thing you'll notice is I'm loading in this VAO twice. So let's fix that. Because that is a tessellated plane that has a lot of detail. So we don't really want it to be loaded in twice. That's bad. So we're just gonna load it in once and use plain VAO. And then make sure to change the material to the water mat, and then set is transparent. True. Now this object won't draw to the we're gonna call it 1.5, because that's basically what it is. And you know what? And then 3. That should all work. Now that we've created this, we don't want this, we don't want this drawing to the depth buffer or anything, or casting shadows. And yeah, we're just gonna make sure to send real quick some pretty important information right here. So we're not going to use this immediately, but so this shader actually requires the width and height of your window. And I'll explain why. This video is actually turning out a lot longer than I expected. But I do want to make sure to explain the data behind everything. And remember how we created this this total time value? We're going to use it. So water, mat. And these are going to get ignored for a little bit until we actually write them in. But it's just so we don't, like, now that we've done this, we don't actually have to touch the CPU at all anymore. Oh, I also commented these out because I was worried that this was breaking it, but this isn't something that you would have done. I did this off camera. There you go. Yeah, so now we actually need to create, and what do we call them? Water vert and water frag. So we need to create new text document. Water vert GLSL water frag TLSL. All right. So, we're going to be going back and forth between these two. But initially, or sorry, wait. So we're gonna delete that file, and we're gonna do something instead of copying and pasting. So we're gonna Control C, or wait, Control C, Control V, and we're gonna call this one water frag. And then we're gonna Control C, Control V, our height displacement, and we're gonna call this one water vert. So when you copy paste the contents of a text file, it can mess up. It can break things pretty easily. So what we just did is we just copied the file and its contents. So we're gonna make this real simple. So first things first, you need to go into here. And we need to set up. Remember how we sent you time? We also did this, but we don't care about that. And we're gonna go, yeah, we deleted it. Okay. So the idea here is just, it's quite simple. So we're gonna create wavy water. In position. So we just read in the position. So pos.z, because this is a z is up framework, plus equals 2. And so we're gonna do a lot of just funky math here. And there's a reason for this funky math. You will see it. So we're going to do sine.position x times 0.90 plus u time times 2.5. So what that does is it takes the x position of that like vertex and multiplies it by 0.9 and then adds time multiplied by 2.5. So this gets you a semi-random number. And then a semi-random number for the x position. So that means that it'll be you doing sine differently based on the x position of the vertex. So different areas will be waving up when different areas are waving down, basically. And then we're gonna do it again with position.x, and we're gonna multiply by 0.76. And then we're going to subtract u time and multiply this by 2.35 plus, and then, so we're going to do position.y now. So now that there's a different one based on the y position of the water, of the vertex on the water. And so the idea with this is that in doing so, we're creating a semi-random wave pattern. Obviously, nothing is ever truly random, but this is just a good way of creating, using time, a really random pattern. I think it's pretty cool. And then you multiply the whole thing by 0.25 because with the numbers that we've been multiplying this by, those waves are going to be insane. You could actually go in and make a uniform for this, actually, and make it so your uniform controls what you're multiplying your wave by. You can make it smaller or bigger if you want. It won't look as good bigger, if I'm honest. As for this, geoposition, we actually want and keep in mind this is the exact. I could literally just write pause. And then out pause. We also want this to be pause, and that is that's it. That's it for the vertex shader. That is all, and that's why we started with that. So the big thing here is we don't care about shadows. We just don't. We just don't. Um, so we remove that. One actually thing that we need to read in, there's this value in um OpenGL in general called GL_FragCord. It gets you the screen space position of your pixel. And this is in number of pixels. So that is why, remember how earlier I had us read in um what's it called? Also, we don't need this anymore because we're not doing shadow mapping. And we can go down here, remove these, remove this line. There we go. That's done. The first thing that we want to read in is uniform, flute, water, transparency, and then right above that, remember how I showed you where we were binding our depth buffer? So we do sampler 2D, and because it's bound to, it doesn't really matter what the name is. We can name it anything. Oh, how did I? There we go. So first thing we want to do is mess around with water transparency. We're gonna water transparency. That's our result now. And so first things first, we're gonna actually test this. If it works, it works. If it doesn't, well then we got some more work to do. I'm assuming it's might get mad. Nope. Okay. And we didn't copy paste anything this time, so there shouldn't be that weird envogl. Oh. Interesting. Interesting. Did we mess up this somehow? That is fun. Okay, we're gonna comment these out real quick. Just in case. Because that is a weird error with the imgui. I don't know how. Don't you just love programming when it comes out of nowhere with a brand new error? For no reason? Alright, well, it would seem that there is an issue. With the imgui callback somehow? So I honestly don't know. I'm assuming that this is just me. Because we didn't change anything like major. But is that gonna see if that works? Oh, accidentally left an I. Should be working. Couldn't tell you why it's not. Like, our shader's fine. I don't know why MGUI is angry with us. What is wrong with MGUI? Unable to read memory. I don't even have any checkboxes in there. Interesting. There are no checkboxes. Oh. I remove these. Might have to pause the video again. Weird that these are all happening. These are not ever at any point issues that I ran into while making this. Yeah, one moment. I will be back. Hello everyone. We are back. So I figured out the issue. Remember when we switched the name of the monkey to object 3? The issue is that this was still calling object 2. So basically that was causing this checkbox, which was behavior, trying to you try to get it from this, but it wouldn't work because object 2 didn't have a symbol move behavior. But now if you run it, after changing this to object 3, make sure to change that. If you run it now, you will be greeted with this. Very pretty water, right? And you know, obviously we can still change the intensity of the height. Then we can also change the transparency of the water. That means our shader is working. Okay, that's a good thing. That means that we are a good chunk of the way in. Now, pretty much we just need to read in the rest of our values. I just wanted to make sure to test that to make sure that it was working. So we called this window width, window height, and window height and window width is being updated and sent every frame, so it doesn't matter if you resize your window. And then call this deepest color, call this mid color, shore color, and then cut off. Oh, you know, mid cut off. Okay. So there's actually this really interesting function that we need to write. But in order to write it, I need to explain to you something. So have you ever gone into your render doc to check out your depth buffer? You know what? I actually have a render doc capture open right here. Isn't that awesome? So have you ever gone into render doc, check out your, your depth buffer? So outputs. And notice that it's all white? Isn't that weird? But then if you bring it up to 0.96, you can actually see things. But it's gotta be it. that high in order to be able to see things. Isn't that weird? The reason for this is so this is distance, and this is the depth value. So you'd think, that it'd be like this. You'd expect it to be like that. Well, really, the depth values are something closer to this. We don't want this. We can't read this. How are we supposed to see this? Like, how are we supposed to see this when it's normal, like, from 0 to 1? We can't see anything. We can't get any data from this. So the big issue is, this is 1, this is 0, and then this is, whatever our distance is. And this is actually based on the near plane and the far plane. And that's actually an important distinction to make, the near plane and the far plane. So how do we deal with this? Well, there's this handy-dandy function that basically takes the data, unpacks it, takes it using the near plane and the far plane, and then repacks it basically into, what you'd expect. It turns the data into this. It converts it from, God, my color is all the way over there. Turns it from this into this. So we need to write that function, because we're actually going to be using our depth buffer. And if you're wondering, actually, why, for example, when we input shadow map, why our shadow map is visible from 0 to 1, this is actually because it's an orthographic projection. And orthographic projection doesn't actually use, it isn't curved. It doesn't use the same curve. An orthographic projection's depth is actually linear, like you would expect. Whereas a perspective projection, the perspective is what causes it to be like this. It's quite literally the perspective projection that causes this, which is really interesting to me. But I don't know about, But so the gist here is that we actually want basically to get we got to unpack our depth, so it's -1 to 1. And then basically we're converting it kind of like you would convert orthographic and projection, basically. I don't know if you noticed that. Because orthographic is -1 to 1, whereas projection is actually like 0 to 1. You cannot have a near value that is less than 1. If you do, it breaks. So the idea here is we're gonna multiply z near, z far. So we're going to get double the double the product of what our z near and z far is. So in this case, our z near is 0.01 and our z far is 1,000. So we're going to get 0.01 of 1,000 and then multiply it by 2. And then we divide by the sum of our z near and z far, so 1,000.01. And then we subtract our expanded depth multiplied by the difference between z far and z near. And that quite literally just linearizes our depth for us. So what we're going to do here actually is we're going to read in our depth buffer. But hear me out. Where's our depth? We don't know. And that's the issue. We don't know. So what do we need to do first? So if we look at this, let's we're gonna save, and so we're gonna actually calculate this thing called screen UV, and I'll show you why. So using that GL frag chord, this is the position of the currently being drawn fragment in window space. So it's in number of pixels. So if we divide it by our window width, and then, we get our GL frag chord divided by window height, we actually get a value between 0 and 1, which is what we're expecting for screen UVs. And actually, if we comment this out and return frag color equals vec for screen UV, and then 0.0, and then U water transparency. You can actually just switch that to a 1.0. And then, we gotta touch main, run it. And now it'll copy over our new file. But the gist here is that, so we don't know where everything is on the screen. So we have a picture, we have a depth buffer on screen. We have our depth buffer, but we don't know where the coordinates on that depth buffer are. Well, if you look, actually, we do. This quite literally, like the colors that we're currently, that it's currently coloring the screen, this quite literally is the screen coordinates for our depth buffer. This is exactly where we need to sample on our depth buffer to see the depth of this, of like the rocks, to see behind this. Because our depth buffer, remember, we're not drawing our transparents to it. So, we actually set this to 1. But we're not drawing our transparents to it. So, it doesn't actually show this. Instead, it shows what's under the water. So now that we've got our screen coordinates, well, then what are we going to do with them? Well, you know that that depth texture that we brought in. Well, this is the expected depth. Texture. This is what it looks like without our water. Screen UV. X, and then we need to pass it our near and our far. That's all. And so what we're actually going to do, just for fun, is we're going to add expected depth. We're going to display our expected depth. Oh, I never touched main. There we go. And so now, we're loading in our main. I don't know if you see this, but you can actually see all of the geometry. You can see everything that is under the water as the depth texture. Because what we did was we got the screen space coordinates of where the water is. So what we have on screen, and I'm actually going to open up RenderDoc to show you. Gotta wait. But I promise this is worth it. So, you know, you can see all of this. We're just gonna print screen, close it up, and RenderDoc will automatically open it for us. So if we actually look here, what we got as an input is this. What we got as an input is this. Do you see that? Do you see? The exact places on screen where the water is, and if we actually overlay depth test, these are the fragments that are being drawn to. You notice? Only those areas were drawn with the depth. We quite literally overlaid the depth buffer perfectly. We quite literally overlaid it perfectly onto our screen. And I don't know about you, but I think that's amazing. So basically that green and red that we saw, remember that RNG is X, like red and green is X and Y. So that red and green texture that you saw in the water was actually coordinates to where in here are we sampling from to draw here. So we got the exact coordinates on this screen. We got all of these green areas on this screen. We got the exact UVs of our depth texture. And then we were like, hey, sample that texture and draw it here. Granted, ours is in 0 to 1, so ours is linear. This is not. This is very much not linear. But we converted it to linear space. And I think, personally, I think that that's amazing and fun. It's really cool to me. But from there, so now we have this magical GL frag chord. GL frag chord is holding the X and the Y value of the current fragment. Now, remember how we enabled the depth or disabled the depth mask, but didn't disable depth test? That's because we wanted depth testing to still happen. We wanted to see the depth test, we wanted to see it was still there. Because the actual depth of a pixel, the actual depth of our water, is actually stored inside of GL frag chord, inside the Z. And then we pass the exact same thing. This actually won't look that impressive, because it doesn't actually change what the water look. It'll just look flat, basically. It won't. So we're not going to display that one. But what we are going to display, float depth difference. So basically, what we're trying to do here is create water that changes color based on the depth. So we have, this is our lake. This is our camera up here. This is our eye. This is what we're seeing. So this is, this is our water. So we have this value right now. Right now, just on the glfragchord.z. We have how far we have the distance in a 0 to 1 range. Very easy to use. And then what we also got is the depth of that. And we got that using our depth buffer texture that we got. So if we subtract the two, we can actually get a vector from here to here. We can get the distance from the water's surface to the shore, no matter what. And so that's what we're doing here. So we're subtracting the expected depth from the actual depth. And it gets us our depth difference. So if we actually go ahead and draw our depth difference, we got to touch main real quick. And you'll actually notice that everywhere where it's at the shore, it's black. Whereas the deepest parts of the water, no matter how far away I get, the deepest parts of the water is white. So basically what this does is it gets the distance from the top of the water to the bottom of the water, or wherever that bottom is. And basically it's all in world space. It's relative to the water now. So now we have an edge on our water, and we can actually change the height, we change the depth, we change the color, we change everything. Also, I never actually pointed it out, but that's the semi-random waves going off. Looks kind of like water flowing. You know? But yeah, so the idea is that now we have full control over everything. We can see exactly how deep our water is. And we can see the exact parts where it reaches the shore of an object. And this is completely dynamic. You could use this data to create something like foam, like sea foam around your objects. You could physically use this algorithm right here to improve the look of if your game has water. Dam defense specifically, this is a great. You already have water. You already have a depth buffer. I would actually recommend this for your game. It would very much be a boon. But that's just one example, like of a that's the only team that I could think of that is entirely based around water. But this method can be used on all sorts of things. And it's used to give your water like artificial depth. But we haven't actually even gotten to that yet. We haven't done anything with it. So now we're going to do something with it. So now that we have all of that data, well, here is the part that I mentioned that was going to be inefficient. And if you find a way to like convert it into mix and stuff like that into different smooth step functions, that will count as your ILE. And I'll put this all in the information for the ILE. But so what we're gonna do is we're gonna actually, so if depth difference is less than or equal to our shore cutoff, first thing, actually, I forgot to make them. Float shore color mod. So this is a modifier for our shore color. Float mid color mod. So basically we're gonna multiply these into our values in order to enable and disable them. So when depth difference is less than our shore cutoff, shore color mod equals 1.0. That is spelt wrong. It's shore color mod. There we go. And then else if, so what we're actually doing here is we're actually assuming, so if it isn't less than or equal to your shore cutoff, then that means it must be greater than shore cutoff. So we're gonna now check mid cutoff. And then mid color mod 1.0. And then else, because if it's not less than mid color cutoff and not less than shore cutoff, it has to be greater than that. So it should just be the deep color mod. From here, we just do the regular, regular stuff. And then we're going to modify our result. And so I actually don't want, I actually would prefer it if our shore color was not textured. And so we're gonna mix based on the use shore color mod. So when shore color is when we don't want to be drawing shore color, it'll just be texture color. When we do, it'll be shore color. And then .rgb, and then you multiply it by the shore color mod. So in the event that it is 1, it'll be 1. And then you add so this will be midcolor.rgb times midcolor mod. So in the event that it's the mid color, it'll just be, so shore color will be 0. So you'll just be adding mid color times 1 plus 0, and then plus u deepest color.rgb times deep color mod. And then, so in the event that it's the deep color, this will be 1. So you multiply the deepest color by 1, plus 0 times mid color, which will be 0, plus 0 if deep color is 1. And then this will just be texture color, and you just multiply into the texture color. Otherwise, if you don't do plus and you just do multiplications, you'll be multiplying 0 into the color of your thing. Last but not least, we actually want to modify our, so u shore color.a times shore color mod. If it is shore color, we want to be multiplying in. So u mid color a mid color mod, and then u. And so if we change the alpha of any specific color, it'll actually change on the actual screen, rather than not changing at all, which would be just, it wouldn't look as good. Like if you want your mid area to be less like more transparent, then you should be able to have it more transparent. Yeah. And then yeah. You now have water that physically changes based on everything. And you actually have control over how far the shore goes out, how far the mid goes out, and you can make it so that you don't even have, if it's above 1 like those are, it'll be deep, but other than that, no. You can make it so you don't have a shore. I like having the shore though. And then you can change the height so that, water's deeper. But you have full control. You can even, as you can see, it's still textured with the water texture that I had in there. Dark. I like it to be a little dark. Yeah, and with a little bit of work, there are actually tutorials out there that you can turn the shore into being textured with foam, like properly textured to be foamy. But it's all really cool, and it's all like just, it's a trick of the eye. It's completely two-dimensional, but you can't really see that based on being above it. But yeah. This is something that you can add to your portfolio and just, mess around with. Just have fun with. You can change the water to be any color you want. You have full control over all of that. You can even change the transparency. Another thing that you can actually do is, the skybox reflection shader that you have. Well, you can also take the skybox and multiply it into this. And that can be your ILE solution. Basically, I'm giving you full control over whatever you want to do for your ILE. It's into, oh yeah, we can also change the individual portions transparency. I don't particularly like having them all changed though. And this is 100% transparency. Yeah, I think it's pretty cool. It could definitely use improvements, and that's what I'm leaving to you. That's the whole point of the ILE this week. It's to make improvements, change things so that this looks like even better water, or that this looks like you could change this to sand texture and make it look even better. It's entirely up to you what you do. Um, I will have the ILE information up along with this video, so you should be able to check it out even while watching. Have a wonderful evening. Bye bye.